combine radical and fractional exponents. Okay, you got to know the basics. Here they are. Fractional exponent, numerator of m, denominator of n. If you were to write that out as a radical, that means the top number, okay, the numerator, that goes as your exponent inside of the radical. Denominator, n in this case, goes outside of the radical as the root. Okay, so in this case, we're talking about nth root of x to the power of m. That's how you would state this, nth root of x to the power of m. Okay, so if you can just remember this rule, you can change and adjust things as needed. So first and foremost, can we turn this radical into a fractional exponent? And the answer is yes. That 4, okay, notice the m and the m, that means it's going to go at the top. So I'm going to have x to the 4th, okay? 4 is my numerator over 3. So this really is just saying x to the 4/3. X to the power of 4/3, okay? Now, power over a power rule states that when we have one exponent over the top of another exponent, we need to multiply them. So 2 times 1/3 just makes 2/3. And now we have x to the power of 4/3 divided by x to the power of 2/3. Hopefully you know your quotient rule because this tells us that we need to subtract our exponents when we're dividing bases that are the same. So 4/3 minus 2/3 leaves me with 2/3. Now I could give my answer like that, or I could give it as a radical, which would be x with the 2 on top inside of the radical, the 3 going to the outside. Okay? Let's go over another problem. I'm going to go through 4 problems with you. 4 problems in this video, so you're going to get lots and lots of practice in, okay? Take a peek at this, make sure you understand it. Notice I went piece by piece. I completely ignored the bottom, just simplified the top. Then I completely ignored the top, just simplified the bottom. And then I'm just using the quotient rule, subtracting 4/3 from 2/3, and we're good. Okay, let's do another one. Give me 1 second to erase. And I'll write it up for you and we'll get started. If you want to pause the video right before I start showing the work on this next one so you can try it out on your own, that's not a bad idea by any means. Okay, we're going to say x to the 5th power, in parentheses, also to the power of 1/3. So we're going to have to use power over power rule there. And then we have cube root x squared. Okay. So if we're going to simplify this, like I said, break it up. Completely ignore all of this and just look at that and see if you can change that into something nicer and neater. And then completely ignore all that and see if you can simplify this into something nicer and neater. Okay, that's where I see students really struggle, is they want to look at the grand scheme of things and they're like, man, this looks like a lot. Okay, well, yeah, just cut it in half. Make it less stuff for you to work on. Okay, so if I'm just focusing here, x to the power of 5 to the power of 1/3. Power over power rule says multiply the exponents. So 5 times 1/3 makes 5/3. We know that this needs to be written out as a fractional exponent, so times x to the, there's your top number, your numerator, there's your denominator. Okay? Now the product rule, which I don't have written over here because I'm assuming we already know this, x to the m times x to the n, you would x to the m plus n. You're going to add your exponents. Product rule says add the exponents. If you're dealing with this stuff, you should already know this. This should not be something I need to teach you anymore. If you're being asked to complete this, you should already have this dialed in. 5/3 plus 2/3 would make 7/3. So my answer is x to the 7/3 or cube root x to the 7th power. Okay? Again, hopefully that's making sense to you. Let's go over a third example. Pause the video, try it on your own, see if you understand this stuff once you get there. All right, this next one's a little bit trickier if I remember correctly. I wanted the third one to be the toughest. Oh, actually, third one's pretty easy. X squared cube root x to the power of 4. Okay, break it up into pieces. Completely ignore all of this. X squared. Can you simplify anything there? Sorry, I'm on the wrong side. X squared. Can anything be simplified? No. Now cover that up. Can something be simplified there? Yeah, we can turn that radical into a fractional exponent. X to the 4 goes on top, 3 goes on bottom. Times x to the power of 2. Now, why is this tricky? A lot of times on this specific problem, I would see kids want to multiply the 2 and the 4/3. No. Product rule says we need to add them. 2 plus 4/3. Ooh, I can't really add a whole number in a fraction. I need common denominators. So what is 2 as a fraction with a 3 as a denominator? Well, that would be 6/3. So let's just change this 2 into a 6/3. Now I can add these two together. Hey, look at that. 6/3 plus 4/3 equals 10/3. And this could also be written as cube root x to the power of 10. Are we getting it? All right, I think we're doing okay. I think we're doing all right. We got one more problem to finish up with. You guys got this. Okay, here we go. Welcome to the big leagues. This problem's gonna look intimidating. Don't let it scare you. Okay, I want you to completely ignore the denominator. Act like it's not even there. If your teacher said, can you simplify this for me? My hope would be that you're like, yeah, no problem. It's a power over a power rule. So all you need to do now is multiply your exponents. 5 times 1/3. Simple enough. Come on, we got this. X to the 5/3. Okay? Now I want you to completely ignore the top. Act like it's not even there. You're only being asked to simplify this. Okay? Well, look at cube root. Because it's a 3, 4 goes on top. See it? Okay. Now, quotient rule. Similar to the product rule, we need to add our exponents. Quotient rule says x to the m divided by x to the n will equal x to the m minus n. You subtract your exponents. So in this case, what we need to do now is 5/3 minus 4/3 leaves me with x to the 1/3. Or in other words, cube root of x. No need for me to show the 1 right there. Okay, and that right there is how you work with both radicals and fractional exponents. Sometimes you'll be asked to give your answer as a fractional exponent. Other times you'll be asked to give it as a radical. Study hard and good luck on your upcoming test. You got this.